is a presentation that's based in part on my PhD work. More specifically, what I'll be telling you about today corresponds roughly to chapters 1 to 3 of my thesis. So let me move on to the next slide. So yeah, in overview, this project, the one I'll be telling you about today, may be seen as a reflection or a meditation on the state of formal philosophy of science as a field of study. And as such, it's also a project that tries to reflect about the philosophy of science. So that's why the focus will mainly be on that rather than on more first order applications of what I'm about to tell you, if you will. But that's just by way of framing the current project and what I aim to do with that. And so yes, I made a choice also when making this presentation to either focus on broad conceptual outline of what I hope to achieve, or to focus on more technical details of the various formal accounts that I'll be talking about. I made a choice to go with the latter, given the nature of the colloquium. Perhaps people might have enjoyed the latter more, but we can always see, depending on people's interests, how that turns out, and we can pick that up in the Q&A if people so desire. So to delve right into it, in overview then, this talk will have 2 parts corresponding to the 2 aims that I have. I know I said 3 in the abstract, but I've shoveled some things around and out too, but the content is more or less the same. So aim 1 and part 1 is to show that formal philosophy of science as a field, so not intrinsically, but in the way that it has been carried out throughout its history and throughout its development, is what I call theory-centric, and that this is problematic for various reasons for formal accounts of science. And then in the second part, we'll get to the second aim of this talk, which is to argue that formal accounts of science may benefit from adopting, again, what I call a supra-theoretical unit of analysis, or macro unit for short. And then, I will discuss some attempts that have been made to launch a formal investigation into such macro units. And I'll make some comments on whether or not I believe those attempts succeed. All right, so part 1 then. So there are 3 things that I should clarify, and then that will already go a long way towards achieving this aim. So I should say what I take formal philosophy of science to consist in, because it's not completely trivial, what the target of my claim is. Then I will clarify what I mean by theory-centrism, and then I will say in brief, but at that point I think we're already quite on board on why it's problematic, but I will give some extra remarks on why this theory-centrism should be seen as problematic. All right, so delving right into the first of these issues then, what is formal philosophy of science? And as with many of these definitions, I just come with some disclaimers, which is that I use the term formal here in the sense of exact or rigorous, and not exclusively in the sense of symbolic, as you might think of when speaking of formal languages, for example. So the term or the way in which I use the term here includes that latter sense, but it's a bit more broad than that, and you can debate on what's the right way to use this term is. This is the way in which I'm using it today, and when I speak of formal philosophy of science. And I should also say that the formal approaches I look at here, or the formal philosophy of science I look at here, involves formal approaches to issues in general philosophy of science, rather than the philosophy of specific disciplines. So you can look at philosophy of physics, to name one prominent example, where you will find more distinctive formal accounts of particular concepts and issues that arise in that field, I'll be focusing on more general issues or issues in general philosophy of science. And I'll specify all of this more in a moment. So first, some more disclaimers. My focus here lies with formal accounts of the products rather than the process of scientific inquiry. And in particular, this means I will have little to say about confirmation, induction, inference to the best explanation, and accordingly, the focus here will also not lie so much with probability theory or statistical methods, rather with other types of approaches, although I should say the particulars and the details of these formal approaches will also not be my main focus here today. As I said, it is more a reflection on the state of these, or on the focus areas of these formal approaches, rather than the specifics of their methodologies, although this will come up more during the end of the talk. So, oh yeah, and then as a final note, this is why, so in light of these disclaimers, I also do not speak of formal philosophy of science as a term in my thesis. Rather, I use a more specific term for all of this, namely architectonic philosophy of science, inspired by some authors that I will again come back to in the end of the talk. Whether or not this is a sensible distinction to make is an open question that I have, and input would be welcome with regard to that question. But if people have strong views on that, then, well, I invite them to share them with me during the Q&A. All right, so with those disclaimers in place, let me then identify the target of my claim. So what do I mean by formal philosophy of science? Well, in practice, it boils down to two main strands of philosophy of science, which people may or may not recognize. So the first of these is the sentential approach to philosophy of science, and the second of these is the structuralist approach to philosophy of science. Now, oh yes, sorry, I jumped here a bit. So yes, the sentential approach, which seeks to formalize science in terms of, well, sentential concepts, sentences. So here we may think of the syntactic methods of mathematical logic, and for the structuralist approach, well, the idea is to formalize various meta-scientific concepts in terms of structure. And again, this has been done in a variety of ways, and we will see more. And this latter one we will see in more detail again at the end of the talk. And one might wonder at this point why I don't use more commonplace terms like syntactic approach or semantic approach. I have my own reasons for preferring this terminology over the more arguably more common one. And if people want to know those reasons, they can ask me, but for present purposes, this is what I'll be using. So what do the sentential and the structuralist approaches consist in? Well, not merely, as people are often prone to think, in the sentential and structuralist approaches or views on the nature of scientific theories. Rather, both of these approaches represent, so they together represent two attempts to expound a systematic analysis of a whole cluster of interrelated meta-scientific concepts. So at this point, it might all sound a bit abstract. So what do I mean by this? Well, if we look at how the sentential approach has been developed throughout the history of philosophy of science, then we find distinct, interrelated, but distinct discourses on such concepts as, well, of course, the concept of a scientific theory. So think here of the Carnap-Hempel syntactic, or, well, as I call it, sentential view of scientific theories. Think here of the DN model of scientific explanation, but also Philip Kitcher's unification model of explanation. Think here of Nagel's account of reduction in science, although again, the extent to which his account in particular is an example of a sentential approach has been a matter of some debate, but we find different approaches, such as the one of Kemeny and Oppenheim, different accounts of reduction that fit into this sentential tradition as well. And then I have a few more examples. So the topics of progress, what it means to have progress in science, and related to that, the whole concept of verisimilitude has been given a sentential treatment by Popper, most famously, but then also by later authors, as mentioned here. And then another big one is the topic of idealization, which has been the subject of extensive discourse in the Poznan School of Philosophy of Science, also working in a distinctly syntactic or sentential vein. And now the same applies to the structuralist approach. So again, this approach extends far beyond the structuralist view of theories, as it is sometimes known, but includes, and these topics or these discourses are a bit lesser, tend to be a bit overshadowed by the structuralist view of theories. So people tend to be not as aware that this approach has been applied to these other discourses, but we find it applies to the discourses on explanation, to the whole discourse on the realism, anti-realism, the realism, anti-realism debate. It has also been applied by Theo Kuipers, for example, to the concept of verisimilitude, to idealization, and in recent years, it has also been very prominently applied to the topic of scientific representation. So what I intend to show by listing all of these examples is the observation that, as I said, these two approaches extend far beyond merely the structuralist and the sentential approach to theories, but they indeed represent whole strands, whole research traditions within the philosophy of science. And for my purposes, this is what I take. Oh yes, and I should note these different formal accounts may or may not be interrelated. So we might think here of the way in which the sentential Hempel, Carnap's and Hempel's views of scientific theories, their accounts of scientific theories, the extent to which that is or is not related to the DN model of explanation, for example. Well, as we might see in this particular case, they are loosely related by virtue of both being formulated in similar systems of logic, but then there are a lot of assumptions made in the Carnap-Hempel account of theories that are not made in the Hempel-Oppenheim account of explanation, for example. So this is to show that these different accounts may be loosely related to each other, but they don't necessarily have to fit into a single well-defined program. In any case, this is what I intend to say when I speak of formal philosophy of science. I mainly identify it with these two traditions within philosophy of science, modulo the disclaimers I gave at the beginning. So I'd be interested to hear in the Q&A whether people think this, whether I'm being reasonably exhaustive here. But taking that as a given for the time being, let me then move on to the next step, which is to say, well, which is to clarify this claim that formal philosophy of science, hence identified, is indeed theory-centric. So what then is theory-centrism? And here we have a nice quote to set the tone. So let me just read this in full. So in 1977, Friedrich said, if any problem in the philosophy of science justifiably can be claimed, to be, and now my Zoom window is blocking part of it. There we go. Can justifiably be claimed the most central or important, it is that of the nature and structure of scientific theories. For theories are the vehicles of scientific knowledge, and one way or another become involved in most aspects of the scientific enterprise. It is only a slight exaggeration to claim that a philosophy of science is little more than an analysis of theories and their roles in the scientific enterprise. A philosophy of science's analysis of the nature of theories, including their roles in the growth of scientific knowledge, thus is its keystone. Well, that already gives us a strong idea of what it means to claim that theories occupy this central role in this particular strand of philosophy of science, of which Suppi himself was a part. So let's try to get a bit more precise on what it then means to say that formal philosophy of science is theory-centric. Well, a naive And a naive characterization of this claim might be as follows. We could simply say that an account of science is theory-centric if it focuses only on explicating the nature of scientific theories. Well, and that might be a noble first attempt, but as our examples, so the examples I showed here and here, as these show, this naive characterization can quickly be seen to be not very apt, since clearly for both the sentential and the structuralist approach, we see that it has in fact been applied to this wide range of other meta-scientific concepts. So it is definitely not. So we can think, for example, of claiming, well, that the sentential approach has been exclusively applied to theory, but then we look at the whole discourse on explanation and the DN model, which arguably had an even bigger literature than the sentential view of theories, and we quickly see that this naive characterization doesn't get us very far. So what else might we say then? And this is where it becomes interesting. So we can try to refine this characterization and say, well, an account of science is theory-centric if it uses a concept of theory as its unit of analysis. And then what does it mean? Well, for it to use it as a unit of analysis. And I will not give a very strict characterization of what this means, but intuitively, I think we all have a sense of what is involved by saying that it's a unit of analysis. So we might, for example, think here of the way in which formal accounts of explanation focus on the question of how a theory might be said to explain a certain phenomenon or a pattern in the world, and then that quickly becomes the focus of the account of explanation. And then we see that any formal definition of, for example, the notion of explanation will then be couched or stated in terms of the concept of scientific theory. And some people might think to themselves, well, actually, for the DN model, wasn't it the concept of law that was involved here? But going back to the original paper by Hempel and Oppenheim, we see that at some point there's a tacit switch they make from the concept of law to the concept of theory in stating their definition of explanation. This is mainly a side remark. What matters here is this refined characterization of theory-centrism. So the intuitive sense in which this concept of theory in one way or another underpins all of these other formal accounts of these different meta-scientific concepts. So is this then the definition or characterization of theory-centrism that we might make do with? Well, almost. So there are some slight nuances to be considered here. So we might think, well, what of the mid-20th century shift of inattention from theories to models, for example? And here people might think of, again, of this structuralist view of theories, also known as the semantic view of theories, where much ado is made of foregrounding the role of models in science, and independently of development in formal philosophy, we have different developments in the discipline which also argue for the prevalence or the importance of models over theories. Might we then still say, well, actually, for at least this structuralist approach to philosophy of science, is it then not more accurate to say that models are the main unit of analysis as opposed to theories? And then this is where I introduce this qualification. Well, I say then that theory-centrism is a claim that the concept of theory serves as the highest level unit of analysis in these different approaches. So in the sentential approach and in the structuralist approach. So here we might again wonder, well, but what actually does it mean to say that this one unit of analysis is higher level than another one? And again, it's not my aim here to really overanalyze what it means to say this, because I think we all have or share some intuition about what this means, but do let me know if I'm mistaken there. But roughly, I want to say here that one meta-scientific concept is higher level than another meta-scientific concept. Well, to say that signals that instances of this higher level concept inform the formulation of instances of the lower level concept. So we might think here of the way in which a theory might be applied, a single theory might be applied to various different target systems, yielding different theoretical models. And again, it's a claim I'm only making about theoretical models, because of course we all know, in line with the theme of model pluralism, that there are also other models which are independent or autonomous of theories. But for the sake of illustration here, think of the way in which a single theory might be said to yield different theoretical models. Well, it's almost a trivial claim when phrased in that way, but in any case, it serves to illustrate the way in which, in this sense, the notion of theory might be said to be higher level than the notion of model. And this will be important in a few moments as well, when I move on to the second part of this presentation. But in any case, with this characterization of theory-centrism in place, so the observation that even in these formal analyses of other concepts, there is still a sense in which the notion of theory is the main concept in terms of which these other analyses are carried out, and it's the highest level concept that is used in that way. Well, what does that mean for the status of formal philosophy of science as embodied in these two research traditions? Well, that's the question to which I'm turning now. So why is it problematic? Well, in the established literature that speaks of theory-centrism, so I'm certainly not the first or the only person to coin this term theory-centrism. It's been used many times, but usually in the literature, it has been used to signal a certain neglect of practice. So focusing here on the contrast between theory on the one hand and practice on the other, and then to say that philosophy of science, and for example, logical positivism and research programs like it are theory-centric in terms to serves to indicate that they neglect scientific practice. And that is, of course, a valid complaint, and much work has been done to explore the ramifications of this neglect of practice in the field since the 1990s onward. My focus, however, is a bit different. So my focus, as I say here on the slide, lies with highlighting the way in which theory-centrism has led formal philosophers to neglect certain supra-theoretical, as I call it, aspects of scientific knowledge, or, well, supras for short. So a supra is then short for supra-theoretical aspect of scientific knowledge. And just to give an illustration here, so supras may be thought of as and here I give it this long list of conceptual, ontological, epistemic, linguistic, methodological, metaphysical, psychological, sociological, material, or other kinds of factors influencing either implicitly or explicitly the formation, structure, and or development of scientific knowledge. So as you can tell, it's a very broad notion that I nevertheless hope that I'm conveying roughly the sense of what this notion involves. So there are these certain things, presuppositions, worldviews that stand above, that either precede or in any case stand above more specific scientific first order theoretical assumptions being made, and that indeed inform the way in which different agents set about formulating their scientific theories. And well, and again, it's almost trivial when formulated like this, but by virtue of being theory-centric, the claim is now that formal philosophy of science has crucially neglected to incorporate these types of supras into the scope of their formal analyses. So, oh, and this is a favorite example of mine that I always try to use of why this matters. So if you take a very extreme example where say you are, as a philosopher of science, interested in explicating the contrast between Aristotelian physics and Newtonian physics, then these kinds of supras become especially important, of course, because then even more so than specific theoretical disagreements on the level of content, what becomes vital here is just the way in which these two different theories of physics are embedded in this whole range of other, well, they're both embedded in these fundamentally different intellectual systems, coming with a whole host of different supra-theoretical assumptions about what it means to do science and what the fundamental nature of the world is even like. So here we have some well-known differences between the two. So the Aristotelian focus on explanation as a goal of science versus the Newtonian focus on description. The fundamental distinction between, or the assumption that there is this fundamental distinction between the sublunar realm and the supralunar realm that is absent with people like Newton, for example, the use of mathematics we might think of, and the role of experimentation in these different bodies of knowledge, or experimentation as a mode of acquiring knowledge, which of course Aristotle was, on some readings of Aristotle, he was very skeptical of, and we all know that for Newton, this was fundamentally different. So this is just to illustrate the importance of looking at supras to adequately capture some characteristic features of different bodies of scientific knowledge. And if we believe that, well, formal methods are this gateway towards more clearly articulating and understanding the nature of science, in particular scientific theories, then we as formal philosophers should of course also strive to include such supras within the scope of our analysis, of our formal analyses. And by not doing so, the upshot of theory-centrism, I should then say, is that we are in fact severely and unduly limiting the scope of our formal analyses. So that's why it's problematic, and that by way of clarifying this claim that formal philosophy of science, thus understood, is theory-centric in the thus understood sense. So now, what does this mean? What can we do with this observation? Well, again, going to my overview, I will now argue that there is a role here for supra-theoretical units of analysis, which I will clarify in a moment. And then I will look at some attempts that have been made to give a formal analysis of such supra-theoretical units of analysis, or as I mentioned, macro units for short. So what are supra-theoretical units of analysis? Well, I should first say that this is not this, I'm not claiming that this is the unique way or the only way in which formal philosophy might address this lacuna, brought about by theory-centrism. So we might also just say, or that instead of promoting this whole new unit of analysis, we simply supplement our studies of the nature of scientific theories on the one hand, with some independent formal investigations into the nature of some supra of choice. So we might, for example, look into the role of metaphysical commitment in the formation of scientific ideas, and then that can be a perfect supplement to our formal study of scientific theory or scientific theories. But as I say here, I'm here interested in exploring a different and a more specific strategy inspired by the work of various post-positivist historians and philosophers of science, and that is to advocate for the adoption of such supra-theoretical units of analysis. And now, what is a supra-theoretical unit of analysis? Now, the best way to get to that, I think, is by way of example. So I think here for example, of Kuhn's notion of paradigm, Lakatos's notion of a research program. We might think of Larry Laudan's notion of a research tradition, Holton's notion of thema, even Foucault's notion of episteme, or Ian Hacking's notion of style, of scientific reasoning, and there are many more I could have mentioned here. So these are all examples of what I call here supra-theoretical units of analysis, with the underlying thought being that, for example, paradigms or research programs or research traditions stand above and guide the development of not just one, but potentially many, or well, at least several different individual scientific theories. And an instance of a supra-theoretical unit of analysis, so for example, a specific paradigm, because that's perhaps the most concrete example to give here, captures the way in which various high-level metaphysical, epistemic, or other kinds of commitments inform, for example, our scientific theorizing. And I should also note here, oh yeah, well, I already gave you the disclaimer that I sometimes use macro unit as a shorthand for this. So that's all fine. So that brings us then to the formal study of macro units, by which I mean, well, how can we, for a given macro unit like paradigm or research program or research tradition, can we in a meaningful way study the structure of such concepts in a formal way? And the answer to this is that it has in fact been attempted, and it has been done by various philosophers of science, mostly working over the course of the 1980s, although by and large this remains an unexplored question or issue within philosophy of science as a whole, where the sentiment usually is that these supra-theoretical units of analysis are the domain of the post-positivist historical philosophers of science, and theory is the domain of formal philosophers of science, and never the two shall meet, or something along those lines. So in any case, we do have two examples of sets of philosophers who have tried to do this, but again, not a whole lot. So these attempts have not led to a whole lot of follow-up work, and today they also remain fairly obscure, which is why I think, if nothing else, it's well, they deserve to be highlighted for the efforts or their attempt to bridge these two different philosophical traditions within philosophy of science. So more specifically, who were these people? So the first set of people were the group of philosophers sometimes known as the Munich structuralists, which includes people such as Wolfgang Steckmüller, Wolfgang Balzer, C.U. Moulines, and Joseph Sneed. And their aim was and one of their aims that emerged over the course of their program was giving this formal treatment of Kuhn's notion of paradigm, and to a much lesser extent, Lakatos's notion of research program. And then in the wake of that attempt, we have two more philosophers, David Pearce and Veiko Rantala, who attempted to do something similar for Larry Laudan's notion of a research tradition, as well as his attendant problem-solving model of scientific progress. Although, for the sake of time, I will only focus on the first one of these, and but much of what I will say applies to the second one of these as well. But yes, let me then discuss in a bit more detail what these Munich structuralists attempted to do. And this program of Munich structuralism is, of course, also embedded within the wider structuralist approach to philosophy of science I mentioned at the outset. So for those of you who were also looking for a bit more illustration about what this approach involves, what I will say over the course of the next few slides will give you some indication of what is involved by adopting a structuralist approach to philosophy of science. And I had a brief disclaimer as well, which is that Carnap's notion of a linguistic framework might also be said to be an instance of a formalized macro unit, but it is not clear to what extent this notion of linguistic framework can actually be used to encode supras that we would actually find interesting, especially if we take this more historical perspective where a supra is some interesting aspect of the historical context in which a body of scientific knowledge is situated. And then, like I said, it's not clear that this notion of linguistic framework can actually encode supras of that kind. There have been people who have argued for analogies between linguistic frameworks and paradigms, but that's a discussion I leave for another day. So here I have just a slide where I briefly give a brief outline of this whole program of Munich structuralism. So it started in the 1970s with Joseph Sneed, was then developed by Wolfgang Steckmüller in Munich. And Steckmüller was the one who first sought to apply this framework of Munich structuralism to Kuhn's notion of scientific change. This was then taken up by Bolzer, Moulines, and Sneed in their 1987 monograph, An Architectonic for Science. And well, as we see here in 2011, it was still alive. The program was still very much alive, and it continues to be a very lively research program to this day, although not very much at the forefront of Anglophone philosophy of science. But again, that's a topic for another day. So what is involved in their formal treatment of paradigms? Well, so like I said here, major theme, expressing Kuhn's theory of scientific change in formal terms. And here we have a nice quote from Kuhn himself saying that Steckmüller, approaching my work through Sneed, has understood it better than any other philosopher who has made more than passing reference to it. Whatever its limitations, I take them to be severe. Formal representation provides a primary technique for exploring and clarifying ideas. So here we have a nice endorsement from Kuhn himself, which also speaks to the program. So yes, let me now say a bit more about what is involved before I will wrap up. So a prerequisite comment, so within the framework of Munich structuralism, and this is quite characteristic of other authors working within the structuralist approach, a scientific theory T is formalized as a class K of mathematical structures called the theory core, plus a class I of intended applications. And so much more can be said about what's involved here in the theory core, and there's a whole apparatus of potential models, partial potential models, etc., that I will not go into here. Also because it's not necessary to grasp their approach to formalizing paradigms. So here we have an illustration of what a scientific theory formalized in this way would look like. So for the theory of classical particle mechanics in dimension n, this theory is given by the class of structures of the form, of the following quintuple, such that the following conditions hold. So this is all fairly straightforward, but this gives you a bit of an illustration about how theories are formalized within this framework. So what does this then mean for their approach to Kuhn's philosophy of science? And here there are three main points that I will just go through. So the formal representation of a scientific T is modified slightly. So modified, I mean, with respect to what I mentioned here. So it is modified slightly so as to accommodate several aspects of the historical context in which the theory is situated. More specifically, we now have what they call a diachronic theory element, which contains the theory core and the set of intended applications as before, but is now expanded to include also this set SC and H, which are, which represent the scientific community that is being considered, as well as the historical period at which we are looking. And moreover, we have here the condition that CS, so the scientific community, intends to apply the theory core K to the intended to the intended phenomena I over the course of the time period H. And so the reason why that's in red, I will mention in a moment. So that's the first step, to expand, to modify this definition of theory. Then in the second step, well, scientific change is then formalized as a sequence. Technically, it's a sequence of collections of theories, but for now we can just think of it as a sequence of theories called a theory evolution. And then thirdly, what is involved, and thirdly, what is involved is that for a given theory evolution E, a paradigm is then a theory, T star, I've called it here, such that for any other theory within this theory evolution, the associated theory core of the paradigm stands in an appropriate specialization relation with respect to the theory core of this arbitrary other theory, and the set of, I'm sorry, I keep using my cursor to move the screen. Anyway, and then the set of intended applications I star is acknowledged as a paradigm class for this arbitrary set of intended applications I. And so now you might ask what that all means, and I will get to that in a moment. So what are we to make of this attempt at a formalization of the paradigm concept? Well, while commendable for its originality and rigor, so it's also much more rigorous than I give it credit for here in this brief summary. But having said that, their approach fails to be satisfying in at least one crucial respect. More specifically, the formal reconstruction of the paradigm concept relies in crucial places on so-called pragmatic primitive concepts. So here we get to the text highlighted in red here. So you might think it is very underwhelming and unsatisfying to stipulate things like SC intends to apply K to I over the course of H, because after all, what does it mean to intend to apply? And then the same goes for acknowledging I star as a paradigm class for I. So what is being done here is this concept is being defined or explicated in terms of irreducibly intentional and pragmatic concepts, which the Munich structuralists wear on their sleeves, because I will not read this out in full, but here they express the sentiment that for the formalization of the paradigm concept, as well as the attendant theory of scientific change, we inevitably will have to rely on pragmatic concepts, and the pragmatic concepts pose us with a special problem in terms of formalization. In particular, these pragmatic concepts can only be formalized, they can best be formalized partially, but not completely, unlike, as they say here, syntactic and semantic concepts. So, like I said, this is an aspect of their account that they wear on their sleeves, but by virtue of that, we might also be left wondering, well, what their formal treatment of paradigms actually achieves. So, like I say here, by relying on these pragmatic primitive concepts to capture some of the key aspects of Kuhn's paradigms, for example, the role of a paradigm qua exemplar, which is a role that's encoded in this notion of I star being acknowledged as a paradigm class for I. So by relying on that, they put, for example, the way in which paradigms may serve as exemplars fundamentally outside of the scope of formal analysis. And of course, the extent to which this is an actual defect of their accounts depends on one's personal stance towards the viability of formalizing pragmatic concepts. But it should be but nevertheless, like if we buy into the notion that the formalization of these pragmatic concepts is at least somewhat attainable and desirable, then this, of course, does present us with a rather unpalatable aspect of their account, and one that also sort of defeats the whole purpose of even trying to couch this concept in formal terms to begin with. Now, having said that, it should be noted, as I say here, that the Munich structuralist account does successfully formalize other aspects of the paradigm concept, such as the way in which paradigms might be said to provide symbolic generalizations. So that's captured, for example, by the first of these conditions in point 3, by saying that the theory core K star stands in an appropriate specialization relation with respect to this arbitrary theory core K. I'm not able here to go into the details, but would be happy to do so if people want me to. So there are 2 further issues as well, as I said in the abstract, but I will not go into those here now, because I'm already running later than I wanted to. In any case, to sum up, theory-centrism unduly limits the purview of formal methods in philosophy of science. The adoption of a supra-theoretical unit of analysis may present formal philosophers with an interesting way to overcome this restriction. And finally, the formalization of pragmatic concepts seems to pose a special problem for the formal study of macro units. And to what extent this problem is genuine or merely illusory remains to be seen. Thank you.